Hello and welcome. My name is Alan Brophy. This is Dr. Denise Fitzgerald. We're here today to talk about remyelination. First question from the people of MS Ireland, Shift MS and MSers all over the world. What is the three-pronged approach to treating MS?
This is really a description that's given to the future of MS treatment as many people see it ideally. And that's really that we treat it in more than one way. So rather than just giving treatments that affect the immune system, we'd also give treatments that would boost neuroprotection. So that's a way of helping the central nervous system build resilience for when damage happens and to protect the nerves that are there. And then the third aspect would be regeneration. So if we can develop regenerative therapies, these would be the types of therapies that would repair damage when damage does occur. So if we can bring the three together, we can dampen down the harmful parts of the immune system, we can build the resilience in the central nervous system to withstand damage, and we can repair damage with regenerative therapies if we can develop all three types of therapies.
Very good. How far along is remyelination therapy?
Remyelination therapy is becoming quite a realistic prospect in the near future, I would say. So trials are ongoing testing remyelinating agents with varying success, but there have been some very promising outcomes from these trials at phase 2 and going into phase 3. And phase 3 is that final phase with a large number of participants that's required in order to apply for approval of a therapy, an official approval. So I'm very hopeful that in the short coming years that we will have remyelinating therapies, and I would predict that it will follow a similar course to the existing MS therapies, where the first ones to come out might not be as effective, but each improvement of a treatment then will be better than the last. So really it's getting that first one is quite key. And then it's up to the researchers and the drug developers to get better and better and better at promoting remyelination.
Tell us about trial architecture.
So trial architecture is about how a clinical trial is structured and put together, essentially. And one thing that is changing in MS trial architecture is that people are starting to think about how can we do trials more efficiently. And one way of doing that is to test multiple treatments at the same time against each other. So these so-called head-to-head trials are a new way of doing trials, or at least a new way in MS. So previously it wasn't unheard of to see 2 treatments tested against each other, but now people are thinking about how can we test 3 and 4 and even 5 treatments against each other, so that you have a control group that can work for each of those treatments instead of having a separate control group for separate trials. And you can also then see how these treatments perform relative to each other. So that's a promising area to speed up the development of new treatments in MS.
So it's cheaper as well, I imagine.
I would imagine so. I haven't sat down and done the economics of it myself. But if you think about having less control groups, that would make it cheaper. But I think more importantly for people with MS, it's the time. So instead of doing one after the next, after the next, after the next, you could have 3 or 4 tested all at the same time. And so you get the answer on 3 or 4 treatments rather than one treatment within the same time frame.
So it speeds up trials by running them in parallel.
Yes, exactly.
What for you is the most exciting avenue in MS research?
I guess I'm biased here because it's the area that I chose to dedicate my lab's efforts towards, and that's remyelination. I'm excited about it because we now have learned quite a lot of detail about how myelin repair naturally happens in the central nervous system. And the more of that information we have, the more likely we are to understand what is missing when remyelination doesn't occur and when there is permanent myelin damage. And understanding that difference between successful remyelination and impaired remyelination will give us a target to use a treatment against. But as I say, I'm completely biased because that's an area that my group work on.
Tell us about the team here in Queens University.
So I'm very lucky to work with a fantastic team here in Queens. It's a really great group of people. There's actually a number of different groups, each working on multiple sclerosis and working on different aspects. And a lot of us are quite interested in remyelination. The team varies. We have some people who are undertaking academic studies like degrees, masters, PhDs. We also have postdocs, so we have people who are qualified with PhDs and they come in and do their postdoctoral training, and they're experienced scientists who will come from different backgrounds, different countries. It's a very international group here, and they will bring their expertise to the labs here in Queens in order to progress our projects. And I should mention that we have strong links to people outside of Queens as well. So we have collaborators in the Belfast Trust, for example. These would be neurologists who help us with patient recruitment, for example, for some research studies. And we also have international collaborators around the world who each have specific expertise that might be needed for one project or another. So while it's a local effort, it's also a global effort. And that's one wonderful aspect of the research in MS, how much cooperation and collaboration there is between teams.